Hi, my name is Marian Figueroa, and for my final project, I chose to do the chemical concept of exothermic reactions. An exothermic reaction is a chemical process that releases energy into its surroundings. The energy usually comes off as either heat or light. And for exothermic reactions, you're going to see an enthalpy change of negative. Your enthalpy is your difference between your reactant in your process and your product. So looking at a diagram showing an exothermic reaction, you can see our reactants on the left with a pretty high energy level. And then after you go through your activation energy, you're going to come down to your product, which, as you can see from this right here, you have a very different and lower energy level, which is your negative enthalpy. That energy we talked about is released because the bonds formed during the process are stronger than the ones that have been broken. An example of this would be a reduction oxidation or a redox reaction, where we see two things happening, a reduction and an oxidation. You have your two different things that are giving and gaining electrons, which end up with a product that is positively charged and negatively charged. An example of a redox reaction would be rust or thermite even. Both of these are redox reactions. They happen at very different speeds. Rust is a very slow, or naturally slow process, and thermite is very fast and very hot, while rust is not. The process for rust, you're going to take your iron, your pure iron, and when it gets mixed with oxygen, you're going to have your oxidizer. This is going to be gaining those electrons in your oxygen, which is the reduction, which is me losing it. And through that process, you're going to get 2Fe, which, as we know, is rust. That's what we know it as. So, up top is your reduction, and then down below is your oxidation. And water is usually involved in this, and it helps that electron transfers from the iron when it bonds with that oxygen to make rust. For my lab experiment, I'm going to be speeding up that rust process using hydrogen peroxide, vinegar, and salt. Your hydrogen peroxide is either going to be an oxidizer, it's going to replace the role of water, and then vinegar and salt are just going to speed up that process as well, as it acts like a catalyst. And then we're going to see when this solution mixes with the steel wool, which is our iron, we're going to get a very, very hot rust, which hopefully is going to allow some steam.
Okay, so we're going to be rapidly oxidizing steel today, steel wool, with a catalyst of salt and vinegar, which act as an electron transfer to rapidize my process of oxidation. And then I'm going to be using hydrogen peroxide instead of water. And when I have this solution all mixed up, and I spray it on my steel, which is my iron in this situation, let's experiment, we're going to see that the iron rapidly oxidizes, and And since the process is so much quicker than usual, we're going to be able to see steam, energy, the heat energy come off of this. Okay, so there it goes. You can see it's starting to rust up, that steel. It's happening at a much quicker rate. Let's pull it apart a little. You can see the rust happening. There you go. You can, I don't know if you can hear it, but you can see it, and I can feel the heat coming off of it. All that is that excess heat from the redox reaction that creates from an exothermic reaction. Oh, it's really hot actually, and really cool.
Now we're going to be looking at our other example of a redox reaction, which is thermite. Thermite is a very high energy exothermic redox reaction. It involves two components: your metal powder, which is your fuel, it's like a pure powder, and your metal oxide, which, like we just did, it could be rust. Thermite is very hot, a lot hotter than a rust, and that process it goes through is where you're going to see your metal powder, which in this case we're going to talk about using aluminum, and you mix it with your metal oxide, which there is again that metal oxide of rust, which is there. Now you see that the aluminum actually bonds better with that oxygen and strips it from your rust, which creates pure iron and a lot of heat. That activation energy required to make this process happen is actually really high. They kind of look like this. So you have your reactants, or your aluminum and iron oxide, and then your activation energy is like way up there. And then you're going to see it come down for your product and all that negative enthalpy, like we said. Some applications for thermite in the real world: you can see it used in welding and metal production. Welding, they use it for like your railroads, making those tracks, and for electrical grounding. Electrical grounding, yep. And then for metal production, to actually get pure metals, thermite is used to get those high purity metals, because it produces pure metal at the end. For my lab experiment, I'm going to be making thermite with some iron oxide and aluminum. It's going to be a 2-to-1 ratio by weight. I'm going to put it in some ceramic containers and lighting it with some magnesium that burns really hot, so it's going to get over that activation energy. And then we're going to see all that energy be released.
Hot as it's supposed to be, but that's as it goes out, that's the thermite it eats more of the aluminum, it moves out further. Maybe there isn't enough aluminum. Maybe the wind is causing it to not react as quick or at all.
So my lab experiment for thermite did not go as intended. I tried 2 different mixtures that I did not show, 3-to-1 and a 2-to-1 ratio. Neither had the reaction I was intending that thermite has, so I'm going to show a little clip from
inside here,
showing
and a little
what
4th of July
thermite
sparkler.
usually has.
And the 4th of July sparkler will throw some sparks down in the mix, give it the activation energy to go. This is an extremely exothermic reaction, so heat will be given off. Our products are going to be iron, solid, and some aluminum oxide. This temperature that we reach is going to be hot enough to melt the iron product that we go ahead and make. So let me get this started. I'm going to light a little Bunsen burner here and light the sparkler. So at the beginning you'll know that it's just sparks, and when this puppy goes, you're going to know that it's more than just the sparks. That's molten iron that's dripping out of the bottom there. That's liquid iron. The cat food can underneath it is just for effect because the iron just ripped right through that aluminum can and it's kind of on fire. Down below in the bucket is some sand, and it's catching the iron so that it doesn't go into water or hit the table or something like that, because it's at about 3250 centigrade. It's very, very, very hot. It's just now cooling down. Extremely exothermic reaction.